Wayne.
Hello, Steve.
It is January 25th, 26th set of reports, and we're going to start out with a look at Venus. Wayne, we got a white paper from our physicist.
Yes, and her conclusions are quite remarkable. I did not know this. I don't know how many people really do. Basically, I'm kind of showing you the conclusion of her paper, which I actually did a video, went through it all. But in essence, Steve, here's the theory, and I think that the theory has strong foundation, that Venus is most likely a comet planet. What I mean by a comet planet, it has all the signatures of a comet. We don't think about comets being this big, planet size, but as we have found out, what we don't know, what we think we know are two different things. Actually, I think they cancel each other out, so we know nothing.
The first thing that occurs to me when I look at this illustration, and it's a great illustration because it shows point blank the difference from a magnetosphere perspective.
Mm-hmm.
And the magnetosphere is how we make our connection to the sun. It's how we get held in our orbit. And this would really explain all of the myths that Venus got bounced around like a ping pong ball.
Right, and it goes in line with the Thunderbolts project. I encourage everyone, go to YouTube, pull up Alien, what is the world, is it Alien Worlds? What is it?
Something about an alien sky.
Alien Skies, thank you, with the Thunderbolts project. Listen, I'll give you the clip notes here, as Steve, as you know. There is writings from ancient tribes in South America that they have found. They have found them in other parts where it appears at one time Saturn dominated the nighttime sky. Also, it was reported that Venus was first seen as this huge comet. And as it passed by Saturn, it got swung into and got caught by our star, our sun. And according to the video, that Mars, what we see today was because Venus stripped Mars's atmosphere in almost a collision of a close come by. It has all the signs on Mars of what we would see as plasma burns. So there you go, Steve. Doesn't this, this is mind-blowing. By the way, I do have, let me go in here because I do have a great website sent in by Jason. Appreciate it, buddy.
Thanks, bud.
Look at this. So the mystery continues, Steve. Why is it that we have such detailed records of our planets, right? We can go right here to this one. So we can see Mercury, right? We can see Jupiter, Saturn, Earth. But Steve, where is Venus? Why no Venus?
Because Venus apparently doesn't have a magnetosphere.
Well, and why is it going in the opposite direction of all the rest of the planets? What could it be that when we see here, look at Neptune, by the way. So we see that there is a commonality amongst many of the planets in our solar system. Neptune, it's still a little screwy, but I think we have to get back to the mystery here, Mr. Olson. Why no Venus?
Wow. And, in the other part of the white paper also talks about because, could you go to the conclusion part of the paper?
Sure, I can. Absolutely. Let me pull it up here.
This is the conclusion of this white paper, and I'll have this paper linked. But in conclusion, something is definitely happening to Venus. It could be increasing ionization of its ionosphere or a perturbed orbit. It is possible as well that Venus is experiencing both an increased ionization of its ionosphere and a perturbed orbit. So that's how we're explaining, or our physicist at least is explaining, the increased brightness of Venus, right? Wayne?
That is correct. That's absolutely correct. And listen, I think that no matter what the stance is, so we all know, Steve, that it's coming in close. This was actually you and I. This is from our show we did the other day from a subscriber that put in the video. And I know that there have been some people that have argued on the math that our physicists did where relative size is concerned. But, I think that that's up. If someone else wants to do the math, we'll then submit it and we'll look at it. But Steve, I think it's just very interesting. We've come across something here. We now know that there's something wrong. I don't know what it is. I just happen to know that for some reason, we don't have, from the planet that's closest to us, Steve, closest to us, and has about the same mass. Wouldn't you think that that would be something that we would want to know about?
It would be. But again, I think it's as simple as it doesn't have a magnetosphere.
Yeah, and I don't understand that.
Yeah.